equals to 2. And they also give you the range x is between 0 and 180 degrees. Find without using a calculator. And they specifically told you without using calculator because it is possible for you to convert your secant to the reciprocal. What is the other trigo ratio that is closely related to secant? Cosine. Okay, what is the relationship between secant x and cosine x? Secant x is 1 over cosine x. Okay, you should have memorized all those already. So it is possible for you to do this. 1 over cosine x equals to 2. Then after that, we are able to use our calculator to figure out, we take cosine inverse of half to find out x. Then after that, we go on to solve the rest of our problems. But they don't want you to do that. They don't want you to use a calculator. So we are required now to draw triangles. Let's continue with making cosine x a subject. So this is half. Okay, these are the first few steps. Since x is between 0 and 180 degrees, this portion tells us that x is in which two quadrants? Okay, quadrant 1 or quadrant 2 okay? Or quadrant 2. But what about this? What does this tell us? Where is our x based on cosine x is equal to half? Cosine x is half. So which quadrant does x belong to? 1 and 1 only? 1 or 4, right? So based on this, we have x in quadrant 1 or quadrant 4. Now we combine all this information together. Where is now my x found in? Only in quadrant 1. No other option already, right? We are limited by the question. It is going to be found in quadrant 1. And now we have to sketch our triangle. If you check your partner's work, did your partner sketch a triangle like this in quadrant 1? With the angle x. Okay, look at work. Do you have this triangle? Because cosine x is half. So, with this triangle, I've got two sides. What do you think naturally we should be doing next?
Find the third side.
Matthew, yes?
Find the third side.
Find the third side. This will be square root of 3. Okay. It's okay to just do mental sums like this. Now we have the complete picture for the diagram already, and we are ready to tackle question for part 3. For part 3 requires cotangent x. Now, Genesis, did you ask for this question? Tell me what you know about cotangent x. 1 over tangent x, okay, absolutely correct. So this is 1 over tangent x. Now based on this, do you think you can find tangent x? Is the triangle useful?
Yes.
Because it helps us find all the trigo ratios that we require. Okay, so Genesis, you should be able to figure this out by yourself already. So let's move on to 5 part 2. Question 5 part 2. So we start with the question again. Cosecant x is 3. Then they also tell you that x is acute. Okay, based on x is acute, which quadrant is x found in?
First quadrant.
Okay, cosecant x is 3. So which trigo ratio should I be converting my cosecant x?
1 over sine x.
Benedict, what should I convert my cosecant x to? Benedict. Cosecant x. 1 over? 1 over sine x, okay. So 1 over sine x is 3. Therefore, sine x is 1 over 3. And since x is in quadrant 1, you should draw your triangle again. It helps us remember the sines of all the different sides. So this is my angle x. Sine opposite 1, hypotenuse 3. What is the unknown side? 9 minus 1. Okay, square root 8. In part 2, they require tangent 90 degrees minus x. Okay. Where is my triangle only has x and I also got a right angle. But now the question wants 90 minus x. Can you identify 90 minus x in the triangle? Yes. Okay, resounding yes. So where is it? It's the only one left, right? 3 angles, 90 degrees, x. The other one must be? 90 minus x. Okay, so this is my 90 degrees minus x.
Square root of 8 over.
Okay, Darius, what do we have for tangent of that 90 degrees minus x?
Square root of 8.
Okay, opposite over adjacent, so square root 8 over 1. And there we have the answer as square root 8. Simplest? Okay, we should simplify this because square root 8 is made out of 4 times 2. And we can evaluate what is square root 4. How much? So we have 2 square root 2. Okay, so this is our final answer. And the last one, cotangent x. It is a similar question to 4 part 3, so I shall not go through this. Follow the steps, you should be able to get it. Okay? So as mentioned, today we'll be moving on to topic 8.8 already, on solving equations, yes? No need. For this one, you can just calculate the values for the sides. No need to write out all the different, the justification why it is so. Okay? Okay, so let's take a look at this graph over here. So yesterday, we started with y equals to sin x graph, right? Then I showed you that, hey, actually we can make use of graphs to help us solve this type of equation. For example, in this case, I've got the equation of sin x is equal to half. How do I make use of my existing y equals to sin x graph to help us solve this equation over here? Okay, so you tell me y equals to half, it doesn't tell me enough. What do I need to do on my graph? Okay, draw the graph of y equals to half. Okay, good. So let's draw the graph of y equals to half. So half is somewhere here, right? So draw the horizontal line, label y equals to half. Okay, how does this graph help me solve the equation of sin x is equal to half? Okay, intersection points. What do the intersection points tell me? Solution. How many solutions do you see on this section? Just this section? 1, 2, 3, 4, 5, 6. Okay, so there are 6 solutions. And what are the solutions? Exactly. If I plotted this graph out very well, very accurate, where are the solutions? So is this one of it? This value over here? Do you know how to find out this value from your calculator? Okay, what do you do? Sine inverse half. And we get 30 degrees. So this is our 30 degrees over here, right? That is our first solution. Then we've got other solutions over here. What is this value? How do you get 150? 180 minus 30. Why minus 30? Why are you so sure that it is minus 30 we get the answer? Sorry? Sin 180 minus theta equals to? Sin theta. Okay, did you memorize that or do you understand why? Okay, good. So we covered that in E-maths before already. Sin 180 minus theta is actually the same as sin theta. So yeah, we can say that this is 150 degrees. But what you just mentioned, Ray C, how is that supposed to help me find this value now? This value over here. Huh? How are you going to find that third solution of x? Plus 30. So 30 degrees over here, we plus another 360 degrees. No, because this is one period, right? So that's a new cycle. It's a new cycle. So if plus another 360 degrees, we will get this value to be 390 degrees. Okay, what about this value now? Okay, the answer is 510. I heard 540 minus 30. Does it look correct on the graph? 540 minus 30? Yes, right, because all these little portions over here, these are 30 degrees, and that is how we can use the graph to help us identify what these values are. But it can be rather tedious and time-consuming, confusing even to find out the last value is 540 minus 30. There is a rather simpler way. Okay, instead of finding out what minus what, we can use our property of this happening periodically because it repeats itself every 360 degrees, right? That's a period, huh? So can you now tell me how do I get from 150 to this unknown angle? Plus 360 because it is periodic. Okay, same for your physics, huh? Now we're going to find out what about the other side of the y-axis. How do we get from, okay, how do we get this value now? These two. And let's start with this one, huh? What do you think this is going to be? 150 minus? Minus 360 over here. So what is 150 minus 360? Negative 210. Okay, so this value is negative 210. And again, we see the same 30 degrees appearing, right? You see this 30 will keep on appearing. Later I'll tell you about the significance of it. Okay, and finally, within this segment of the graph, what is this value over here? This value? Okay, tell me how you get it. 30 minus 360, and we get negative 330 degrees. And then over here, we've got our 30 degrees again. This can be repeated over and over again depending on the range of the question. So if I want a number of solutions within the range from negative 360 degrees to 540 degrees, I've got 6 solutions. And they are as such. Out of all these angles, there is one angle that kept appearing repeatedly, again and again. What is the angle? 30 degrees. Do you remember the name for this 30 degrees? Basic angle. Basic angle, and we usually use alpha for it. Yes? Meaning, if I am able to generate this basic angle of 30 degrees, I can find out all the solutions already, based on the graph. But drawing graph can also be tedious. We are able to translate this graph. Yes, Darius? You can draw one full cycle, but what if the question requires more than one full cycle? Okay, then later I'll show you how to deal with the range. So instead of drawing graphs like this, we're going to translate this to become a circle. Yes, thank you, Jia. Okay, so circle over here. Okay, so the first one is y. Okay, based on the original question, sine x equals to half. So we know that this falls in the first and second quadrant, right? So that is why I drew these two triangles in the first and the second quadrant. I will have one value of x over here. Let's call it x1, which gives me sine of this angle equals to half. So because all our trigo, they are all ratios. So sine gives us, what is the trigo ratio for sine? Sine theta is which one over what over what? Y over r. Okay, r is the radius. So this vertical portion, we can call it 1, and this will be 2, isn't it? Opposite over hypotenuse, 1 over 2. And similarly, they share the same y value on the second quadrant. So we again get 1 over 2. And this angle is now called x2. So you see, we've got x1 and x2 found in our circle over here. Radius is 2. So when we attempt to solve this question, sine x equals to half, we first find the basic angle. That acute angle, which is what you have been doing since Sec 2. Just key into your calculator, sine inverse half. And your calculator tells you 30 degrees. Now that you are learning A maths, you must know that this 30 degrees is going to be used to generate all the other solutions. Okay? So this x1, it happens to be our alpha, which is 30 degrees. then based on the diagram, if this is 30 degrees, our x1 is 30 degrees, symmetrically on the other side, this must also be 30 degrees. Can you now use geometry to tell me the value of x2? How do you get 150 then? 180 minus 30. So we are able to see that based on this circle, we will get 150 degrees for x2. Was it the same as in our graph? Same, 150 degrees and 30 degrees. So it repeats. It is a different representation. But what is the drawback of this circle compared to the graph? How many solutions did the graph give you for this section? 6, right? The circle gives you how many solutions? Only 2, right? Then what about the others? Can I get the same solutions from the circle? How? How am I supposed to get this 390 from my circle? Let me remove all these first. Let's start clean. Okay, so I've got the basic angle as alpha, 30 degrees. How am I supposed to get the 360 degrees from here? Okay, think about it first. Ernest, how do you think we can get 390 degrees from this circle? Okay, how about you do it? Okay, so he's going to demonstrate how we get 390 from here. Okay. Press the button on the side. Hey, don't laugh, later I let you try. Okay, thank you. So we see that he went one round. He ran a complete cycle, and when he reached the horizontal axis again, he continued up the same angle. How much is this angle again? 30. So one round will be 360 degrees, then he plus the 30 degrees again, right? And that is how he got it, 390 degrees. It is the same representation, it is a different representation from the sine graph, but it works the same way. So earlier on, we had another solution over here. So this was, okay, let me clean up everything. Earlier on, this was our 150 degrees. So again, we can go one full cycle. So back here, 360 degrees. Then I plus 150, and I get my fourth answer. So instead of going this way, I can also go the other way. I go clockwise, then it will be negative angles. Okay, and that's how we get the answers from the other side. Can? So this is the explanation of the steps that we're going to be doing later on in a short while. Okay, we're going to translate all these into very standard steps that will help us solve trigo equations. Okay, so here it is. Whenever you want to solve trigo equations in a form that looks like this, cosine x equals to a, for example, or sine x equal to a, tangent x equal to a. As long as it looks like one of these, where a itself, the value over there, a, can be positive or negative, you can use these steps. Yeah, I'm recording. Okay, so now, the steps are on the left. These are steps 1, 2, 3, 4, 5 steps. I will explain them with our work example. What do we have? Work example 19. So on the right hand side, work example 19. The question is, solve the equation cosine x equals to negative 1 over 3, and the range given is from 0 degrees to 360 degrees, inclusive. Okay, so let's take a look. Does this part, cosine x equal to negative 1/3, fall under one of the circled categories? Does it have the same form? Yes, right. Okay, cosine x equals to a, and I tell you that a can be positive, can be negative. Okay, so now, first step, we write down let cosine alpha. Remind me again what is alpha? Basic angle, which can be easily found from our calculator. Okay, so I literally write down let cosine, because in this case it is cosine in the question, so I write down cosine, and now I introduce alpha. I don't care what the question says, it could be cosine x, equals to negative 1/3. It could be cosine 2x. It could be cosine x plus 5. Whatever. I am just going to write down cosine x equals to. Let's see what is this symbol again. What are those two? Modulus. Because I only want positive numbers. The value of a over here could be negative 1/3. It could be 1/3. It could be positive, negative numbers. Doesn't matter. I just want the positive value first because I'm finding basic angle. Okay? So now, we let this be 1/3. Just literally write down this. Now, the step number 2, find alpha. I believe everybody can do this. Take out a calculator, start finding out what is alpha. Go and practice. Make sure you are in the correct mode. Is this question in degree or radian? Degree, yes. 70.5 to 8. Okay, about this is sufficient already. So I've got my basic angle now. Third step, determine the quadrant that x lies in. This x over here refers to whatever is in the question. In this case, x lies in quadrant 2 and 3. How do you know it's 2 and 3? Cosine x is negative, but okay, so what is the tool that we use to help us remember? Okay, this one A, next one S, E, C. Okay, use this to help you remember. So since cosine x is negative 1/3, cosine x is negative 1/3, what does that tell us about the quadrant that x lies in? 2 or 3, because here it will be positive, over here it will be positive also. Okay, so x lies in quadrant 2 or 3, n or 3. Okay. Now, part 4, determine the range of x. Range of x is over here. Nothing to do, we just copy it down. 0 degrees and 360 degrees. Later I'll show you why this seemingly redundant step is going to be important. Right now, this is a very basic question, so we don't have anything much to do, we just can copy it down. Now, step number 5, we're going to use the basic angle to find all the x within the range. So you see, they define the range for you. Otherwise, you'll be calculating for so many different values of x. Yeah, there will be infinite solutions. Okay? So quadrant 2 looks like this, and this is my x value. Quadrant 3 looks like, sorry, not this. Quadrant 3 over here. This is going to be my other x value. Okay? Now, let's find the first x value for quadrant 2. X would therefore be, we already found the basic angle, 70, this angle over here, 70.528 degrees. Then this basic angle over here, 70.528 degrees. Okay, now first one, in quadrant 2, what is the value of x?
180 minus 70.537.
Yeah, and we are able to do that because I drew out the diagram. I know that this basic angle is 70.528. Therefore, the solution for x is 180 minus 70.528. If you are doing Emacs, you will tell me the reason. Adjacent angles on a straight line. Am I right? Yes. So this is the first answer. Or, there is a second answer. How much is this now? 180 plus 70.528 degrees. So now I have two answers. Remember, there are supposed to be infinite answers, right? So with these two answers, in quadrant 2 and 3, I am supposed to go and test out to see whether there are more answers or not. And the answers repeat themselves every how many degrees? 360 degrees. Let's start with the first one. Okay, 180 minus 70.528. Mental sums or calculator, find out what that is. 109.472. 109.472. I plus 360 degrees. Does it still fall within the range? See, I told you to write down a range, right? There's a reason why. I told you to write down a range. You take 180 minus 70.528, you get 109.472. You plus 360. Are we still going to be in the range? No. So don't bother adding 360. Then now the answer in quadrant 3 is a bigger number, right? 180 plus 70 is 200 over. You plus 360, are you going to fall within the range? No. So we don't bother adding. Then now that we conclude that I don't need to add 360, should I bother adding 720? Yeah, don't waste time lah. Should I? Now, how about the other side? I need to minus also because it repeats itself on the other side. I am supposed to minus 360. Okay, this value, if I minus 360, will I fall within the range? No, so don't bother. Next one. This test is important. You need to do this to find out whether you miss out any solution or not. Next one, 180 plus 70, you still get 200 over. You minus 360, do you fall within this range? No. So how many answers are there? Two. Go and evaluate them. Round it off. Get the answer. Okay? So these are the steps. I'm gonna do it one more time for practice now 19. Let you get a hang of how we can use my 5 steps to solve all the questions. Okay, so now this is practice now 19. Question 1. After you practice, you should be faster already. So question 1, we've got cosine x is negative 0.81. And the range is from 0 to 360. Okay, I use this time tell you a bit about English. It says between 0 and 360 degrees. Does it include 0? No. Does it include 360? No. Okay, very good. The answer is no. If they say from 0 to 360, does it include 0? Yes. Does it include 360? Yes, you need to know that. Okay, so now that is why I didn't put the equal. It is just greater than 0 but less than 360. It is not greater than or equal to. Alright, now let's start with the first step. Cosine. Oops. Okay, so first step, we write down let cosine alpha equals to, what do we put on the right side? 0.81. Don't care about the sign. Positive or negative, just put on the positive value. The sign will be taken care of in the subsequent steps when we decide which quadrant it lies in. So now step number 2, find alpha. Everybody do that. How much is it? 0.904. Okay. Determine the quadrants that x lies in. So x in quadrant 2 and 3 again. 2 or 3. Determine the range of x. Again, nothing to do. We just copy it down. 0 and 360. Then I'm going to just do a quick sketch for quadrant 2 over here. This will be my first x value, and this is my alpha, which we already found for quadrant 2, and then for quadrant 3, it's like this, where this is alpha again. And this is my x, my different values of x. Step number 5, use the basic angle to find all the x. Now the first value of x will be equal to, for the second quadrant, according to the diagram, alpha we found is 35.904, the basic angle. So what is the first value of x that we have? What is the working? Working for the first one, come on, x1. 180 minus 35.904. That's the first answer. Then we have a second answer. In the third quadrant, we have 180 plus 35.904. Do we have any more answers? Yes, no, or maybe? No. Well, you're so sure. How are you all so sure that there are no more answers? You plus those two answers, you plus 360, they fall out of range. You minus 360, they fall out of range also. Therefore, we only have these two answers. So, get an answer, round it off. You see the steps are the same. Okay? Anybody has questions on how to utilize these 5 steps? For this case, you put the answer in 1 dp because it is in degrees. Answers in degrees, you leave it in 1 dp. Answers in radian, you leave it in 3 sf. Alright? Okay, before we let you do some practice questions, I need to ensure that you know how to use the diagrams to find the basic angle. So for example, in quadrant 2, if this is alpha, and what is this value of x in the second quadrant? Okay, so you are expected to write down that x is equal to minus alpha. And alpha is a basic angle we will definitely be able to calculate. Okay, what if it is in the first quadrant? This one is alpha. So what is x? Alpha is the most basic one. What about quadrant number 3 that you have been trying for the past 2 questions? Wait. This x, this alpha. So what's x? 180 plus alpha. And the last case, quadrant number 4, this is x and this is alpha. What is x? I heard 270. 360 minus alpha. Huh? It's always 180 or 360. But if you want to make life difficult for yourself, if you want to make life difficult for yourself, you can use 270. How? X is going to be 270 degrees plus this part, which is 90 degrees minus alpha. And then you still get 360 minus alpha. If you want to make life difficult for yourself, right? Does anybody wants to do that? No. So everything has a reason why we are doing that. And now you get to practice using these 5 steps for question. Okay, exercise 8E. Exercise 8E. Questions 1A, B, D, 2A, C. Right now. You get to do them right now. Okay, so let me show you question 2C over here. We have cosecant 2x is negative 2.342. Now we need to class, quit talking, make you come on and do. Cosecant 2x is negative 2.4342. We have to convert our cosecant to become which trigonometric ratio? Sine. So 1 over sine 2x equals to negative 2.342. Actually, I think most of you should be able to do this already. Sine 2x is simply 1 over negative 2.342. Okay, I think you all can do this. Can skip the middle step. And this gives us, let sine alpha be equal to 1 over 2.342. Because I don't like to have too many intermediate evaluations. I like to keep the number as original as possible. So this is my basic angle alpha. Okay, I ignore the negative sign. So now alpha is going to be equals to sine inverse. So sine inverse, is this in degree or radian?
Degree.
Okay, I need to change my calculator back to degree. So inverse sine 1 divided by 2.342. Oops. 25.2764 degrees. So this is my basic angle. Done. What do we need to do after finding basic angle? Determine quadrant. Okay, let me continue on this side. So the angle over here is 2x. So I write out 2x lies in quadrant 2x. So based on this, it lies in quadrant 3 or quadrant 4. Now the next step, determine the range of x. So x, in the question it says it is from 0 degrees to 180 degrees. My question is 2x. So 2x ranges from 0 degrees to 360 degrees. Okay? And the final step is to use alpha. Use the basic angle to determine the values of x. So we write down 2x is now equal to, in our third quadrant, it will be 180 degrees plus basic angle. How much is the basic angle? 25.2764 degrees. Or, now in the fourth quadrant, it will be 360 degrees minus 25.2764 degrees. This is for 2x. But remember, when we are solving, eventually we need to find x. So before I continue to divide the answer by 2, I need to consider, hey, the first answer over here, plus 360, does it fall within range? No, it doesn't. I minus 360, does it fall within this range? Doesn't. How about the second one? Also no and no lah. So I have 2 answers, they are 180 plus 25.2764, 205.2764 degrees, or 360 minus 25.2764, 334.7236 degrees. So these are the two answers for 2x. So I evaluate x. I already have the last answer stored in my calculator, right? So I just press divide by 2. I write down the second answer first, 167.3618. And the first answer is 205.2764 divided by 2, 102.6382. Round them off, 102.6 or 167.4. Are these the correct answers?